In 2003, Singapore's National Water Agency launched an unprecedented program. Using 2 new facilities, they plan to provide more than 50% of their nation's water supply by recycling wastewater. And yes, we do mean that wastewater. While this might seem like a desperate decision, this program had been planned for decades to ensure the island nation never ran out of clean water. And today, as climate change increases the frequency and duration of droughts worldwide, more and more regions are facing this problem. But is it really safe to reuse anything we flush down the toilet? To answer this, we have to understand exactly what's inside this cloudy cocktail. Wastewater is classified into several types, but the primary 3 are: gray water used in sinks, bathing, and laundry; yellow water containing just urine; and black water which has come into contact with feces. Globally, we generate enough wastewater to fill about 400,000 Olympic-sized swimming pools every day. In cities and towns with sewage systems, this wastewater combines in underground pipes, which actually aren't filled with feces. The average 4,000 liters of sewage contains only a single liter of solid fecal material. But sewage is still rife with dangerous contaminants, including billions of pathogens and microorganisms, trace chemicals, and excess inorganic nutrients that can pollute rivers and lakes. So even if we aren't planning to drink this concoction, we still need to clean it, which is why sewer systems typically run to wastewater treatment plants. Most plants remove major contaminants such as feces, pathogens, and excess nitrogen from all the water they process. And this involves a ton of biological, chemical, and physical interventions. Some of the most important include settling tanks to remove large particles, biological reaction tanks where microbes eat unwanted materials, and chemical disinfection processes that kill pathogens. After these procedures, typical treated wastewater in the US is already cleaner than most natural bodies of water, making it safe to discharge into rivers and lakes. If we plan on reusing the water for non-potable purposes, such as irrigation or washing cars, it gets even further disinfected to prevent bacteria from growing during storage. But if we want it clean enough to drink, there's much more treatment to be done. One common process includes microfiltration, where membranes with pores 1/1,000,000 of a meter across filter out small particles and larger microorganisms. Next, the water passes through an even finer reverse osmosis membrane, which can remove particles as small as 1/10 of a billionth of a meter. This membrane is semi-permeable, allowing water to pass through, but stopping things like salt, viruses, or unwanted chemicals. After this stage, UV lamps are plunged into the water, emitting radiation that permanently damages the genetic material of any lingering life forms. Sometimes UV disinfection is then combined with further disinfection processes that use chemicals like hydrogen peroxide to handle a wide range of microorganisms and micropollutants. At this point, the treated wastewater is tested rigorously. And if it passes, it can safely enter the typical pipeline for drinking water, going through the standard treatment procedures before joining the municipal supply. This approach is called direct potable reuse, but even though it's perfectly healthy, there's still some concern with such a direct system. Instead, most places opt for indirect potable reuse, where the treated wastewater is discharged to an environmental buffer, such as a reservoir, lake, wetland, or groundwater aquifer. After some time in this environment, any lingering chemicals from the treatment process will diffuse and degrade. Then, the water can be extracted and enter the drinking water pipeline. Indirect potable reuse is the process used in Singapore, and it's become an increasingly common lifeline for arid regions in the US. But this system is only feasible in places with centralized sewer systems and infrastructure for pumping water into people's homes. This means it can't help communities dealing with the most serious sanitation issues, where access to clean water is a daily struggle. Researchers are investigating smaller-scale technologies to recycle sewage into potable water on site. But helping these communities in the long term will require us to take a closer look at all the water we've been wasting.